the solution to a system of equations, and a system, and here's two equations, two unknowns, so there's something they have in common, is an ordered pair. Now this is where they cross, where the two equations intersect. Or cross. So that says, is this where they cross? Is 3, -1 where they cross? So that's a check. They're either cross there, that's a shared, this happens to be a shared point. So do these two equations go through that point? That's what the idea is. So if that's true, then x minus y has to be -4, where x equals -3 and y equals 1. Well, if x is -3, it says -3 minus y is 1. Well, -3 minus 1 is -4, and it checks. So this coordinate point is on that line. Question is that it is also on the other line. 2x plus 10y equals 4. Is it true that 2 times -3 plus 10 times 1, is that equal to 4? So that's the question. Well, -6 plus 10 certainly equals 4, so it checks. So the answer is -3, 1 is a solution. Now, when you're dealing with systems of equations, there are 3 types of solutions. Doesn't matter how many equations or how many variables you have. You can have one solution. Now, what that would look like is I'm going to draw 2 arbitrary lines. And maybe something like this. And it would cross at a single point. So this would be your solution. His type is consistent. That means it has a solution, and the number of solutions it has is 1. And that's where they cross. Now, you could have 2 lines that are parallel. Now, parallel lines don't cross at all, so that means this has no solution because they don't cross. And so the type is called in, meaning not consistent. The number of solutions it has is 0. The third type is where the 2 lines are actually the same line. That means they have every coordinate point in common. And since they have every point in common, its type is called dependent. And it has an infinite number of solutions. And that is every point that is on that line. Every coordinate point on the line. So if every coordinate point on the line, so that says this whole line is the solution. Anything that's on this line would be a solution to the system. We're only talking about now systems of 2 equations and 2 unknowns. There are three ways of solving these guys graphically. That's a way I don't particularly like because it's not very accurate. Substitution, and we've been using substitution. We'll use it again at the end of chapter 6 and 6.6. And something called the addition method. Another name that's attached to it is elimination. The elimination method, the addition method. So what would I do to go graph? Now, the one thing that I would probably do is I'd use the intercept method of graphing, namely if x minus y equals -4, especially on this one. So I'm going to use the intercept method. And if y equals 0, that goes away. X is -4. And x equals 0, x goes away, y is 4. So it's x equals -4, 1, 2, 3, 4, y equals 0. X equals 0, 1, 2, 3, 4. And I notice that it lines up with my dots, so I'm going to try to do that very carefully. And I will actually use a straight edge for this, believe it or not, to see if I can get things lined up right. So that takes time. And so there's my line. And this is the line x minus y equal -4. Now, for those of you that are going to be going into the business area, you're going to be doing something called linear programming, where you're going to be looking at lines and intersections of lines and what have you. It would be helpful to label your line. So you'll find that's going to be the case. I'm going to change pen colors as soon as I can find one. And this says that x plus y equals 6. Well, my graph paper only goes to 5. So using the intercept method of graphing, that gives me a y value of 6. This gives me a y value of 6. So that's not a good way to do this particular graph. So I'm just going to put in x and get out y. And if x equals 1, y equals, I would have 1 plus y equals 6, or y equals 5, so 1, 5. And if x equals 2, that says 2 plus y equals 6, y equals 4. So 1, 5, and 2, 4. And now I'm going to line my dots up. And this is the line x plus y equals 6. So if I look, it appears, then that's the problem. If this were a fractional solution, I'd really have an issue. But it appears to be 1, 5 is where that appears to cross. So that's a apparent solution. So let me check. Well, that says x equal 1, y equal 5. Is it, I know it's true on the second equation because there's that coordinate point. It's 1, 5. Well, what about on this guy? X minus y equal -4. So 1 minus 5, that's certainly equal to -4, and it checks. So that is a solution. So again, this would be my answer to this particular equation. It is consistent with one solution, and it'd be the coordinate 0.1, 5.